Hello, everybody, and welcome. Thanks for joining. First of all, I'm Andrea Campanella, member of technical staff at the Open Networking Foundation, and also a member of the Volta team, where I work with the rest of the community to bring Volta to production. So let me start first with the outline of our talk today. I'm just gonna briefly discuss the SEBA reference design and architecture to put everybody into perspective of where we are and where we stand in terms of the general architecture. Then we're going to discuss the Volta architecture itself and the project state, so where we are. Then we're going to go into some details of some deployments of the operators that we work with, especially Deutsche Telekom and Turk Telekom. Then we're going to focus on the Volta 2.6 release, some of the enhancements, some of the new features that were brought in with the 2.6 release that was released in December. And then we're going to look at the Volta 2.7 roadmap and also beyond the 2.7. So the upcoming features and elements that we are working with right now. Then I actually want to have a Q&A session at the end. So I left some time at the end for everybody to ask their questions. And so we can have a chat about what your interest is. So first of all, to put this into perspective, we need to start with the SEBA reference design. This is where the initial idea came together. And SEBA is a lightweight platform for the development of solutions for broadband access. It's based on a common infrastructure. It uses and enables multiple virtualized access technologies such as GPON, XGS-PON, EPON, G.fast. It does not require any VNF processing on a server for the data path to work, meaning that the data path never hits a compute node, and thus is what we call a fast path. It's all comprised of microservices, which work one another and leverage each other's API to achieve the common end goal of provisioning a subscriber, multiple subscribers, connectivity. Recently, we started working and have a final draft that is under member review of the SEBA reference design. So the reference design 2.0 builds upon the first version of the reference design that was released a while ago by ONF and the operator partners, and adds disaggregated broadband network gateway, the BNG, comprised of two different elements that are brought together thanks to the P4 runtime capabilities and to a custom pipeline, the OLT and aggregation switch, as we will see later, make the BNG user plane. And also there are going to be some BNG control plane applications. We also define the per OLT Volta stack modeling for scaling, meaning we define how much we can scale with one or multiple Volta stacks, and we're going to talk about this in detail later. We also use northbound detailed APIs. It defines more northbound out of the network edge mediator, but also out of the different components, more specific APIs. And also introduces the concept of the device management that was completely absent from the first reference design version. As I said, it's under final member review and will be released after final approval of the ONF group of member and partners. So let's now dive a little bit deeper into the architecture of the 2.0 of the reference design. As always, we start with the RG and the ONU on the PON and the core of the operator network. This is where the boundary is. Everything in the middle is what SEBA defines. We have, as you guys know, white box OLTs, or in general, any OLT. We also have white box switches on top of which we attach some compute and some servers. And these switches act as a fabric. And the white box OLT with the switches together are the BNG user plane that I was mentioning before. The software stack instead starts from a common infrastructure of Docker, Kubernetes, and Helm. And then we deploy some microservices. So we start with the Volta microservice, which we will go in detail later. On top of the switch, we deploy Stratum, the Thin Switch OS. There was a webinar about it a few days ago. So if you're interested, go look at that. And on top of these two, we put the ONOS SDN controller that manages Volta via OpenFlow and Stratum via P4 runtime GNMI with OpenConfig models. On top of ONOS, we install some specific apps to target our use case. The Volta control apps, meaning the OLT app, AAA for authentication, the HTTP-L2 relay. Then we have a fabric control, which is Trellis. And then we have the BNG control plane applications that manage the BNG user plane in terms of P4 pipeline, but also rules that need to be installed in both the OLT and the switch to provision end-to-end data path. On top of this, we have what we call NEM, which is the network edge mediator that does the end-to-end orchestration for all these microservices, but also exposes the whole SEBA pod to the operator OSS, BSS, or also ONAP via a local adapter. Today, we will mostly focus on the Volta side of things, meaning the access. It's going to be a combination of ONOS that manages Volta on top of the common infrastructure and OLTs and ONUs. So let's dive in a little bit in that. What is Volta? Volta is a set of microservices that manages the ONUs and the OLT via a common control and abstracts the spawn network through different layers to the different higher system of an operator. So we start with the ONUs and an OLT, and then we provide what we call the adapters. The adapters are both the OpenONU adapter and the OpenOLT adapter. The OpenOLT adapter is the responsible one to talk to the OLT, while the OpenONU adapter handles the OMCI messages for the ONU configuration. Volta is made, as I said, of microservices. So we need a messaging bus to communicate between the microservices. That's the choice of our architecture. And it's also used to communicate events and data to the outside world. On top of the message bus and the adapters, we use a common abstraction in the Volta core. The Volta core is the heart of the system and handles adapter registration for different types of OLTs, but also handles requests from the northbound that arrive to him via the OpenFlow agent. The OpenFlow agent is then connected to ONOS as the SDN controller. All the information within Volta that needs to be replicated and stored in case of failures in a persistent data store is done via etcd. So Volta supports multiple brands of OLTs and ONUs, and we will have a more detailed look at that later, but also multiple services such as high-speed internet access, voice over IP, video on demand, and IPTV via the ONUs. But not only for one operator, but also for multiple operators. We have this concept of workflows, which are configurations that you do to the different pieces of Volta with different types of configurations. Again, some take JSON inputs, some take other type of flags, and that specify how a subscriber is handled, because there are differences between the different operators we work with. So I've seen there are already some questions coming in. Thanks for that. I'll address them at the end if you guys don't mind. the different operators we work with have different requirements. For example, in the case of AT&T, there was a requirement to handle ePOL authentication. That was not a requirement in case of Türk Telekom or Deutsche Telekom. So the different workflows configure the system in a proper way to handle these different requirements. Also, as of recent, I mentioned it in the SEBA RD 2.0, we started introducing the device management interface, which is the standard API defined in protobuf to handle non-Volta related operations, meaning non-data path related operations, such as software upgrade of the OLT image. So there is an important notion in Volta, which is the fact that we support multiple type of ONUs and OLTs. The reference architecture that you see here is done via all open source software with an open OLT adapter, an open OLT agent on top of a white box OLT. Usually it's an edge core white box OLT. But nothing prevents another vendor to bring in their OLT. Their OLT comes with their own OLT agent, with their own software, and their own management interface. And that then becomes integrated into Volta by the use of a different adapter. That adapter can communicate whatever southbound to the device it desires. We have seen it done via netconf, for example. But the important part is that it uses the same exact interface to the core. That interface is defined in protobuf, and it's upstream. You can see it, and that is the interface that the core accepts towards the adapter. So any vendor that comes in with an OLT adapter that implements that interface will be fully compatible with Volta. For the provisioning of the data path. The same applies for the device management interface. The vendor might come in with their device manager that talks to the device, whatever protocol they see fit, or whatever protocol they support on the device, for example, netconf, but needs to talk the same common device management interface, which is again an open source protobuf defined API that is under ONF, and it's based on RFC 8348 and the Broadband Forum WT383 set of APIs. It's mostly a protobuf translation of these two. And that is so that the operator NEM does not have to care about each protocol of each different vendor and each different model of each different vendor. The operator OSS PSS just needs to be integrated with the device management interface as it is integrated with the ONOS APIs, and they shouldn't be implementing each vendor specifics. Those are abstracted to the operator by the adapters on the Volta data plane side and the device management interface for the management side. So within Volta, it's also very important to handle scale and failure. So the first thing that we need to do is to distinguish a couple of key elements. What we call the Volta infrastructure and what we call the Volta stack. So the Volta infrastructure is mainly stuff that it's not pertained to the Volta per se. It's an SDN controller, ONOS. It's a storage system, etcd, and it's a bus, it's Kafka. It has nothing to do with PON per se. But the Volta stack instead is the one that handles all the PON specifics. And that is comprised of the OF agent, the Volta core, and the different adapters that we just talked about. Each Volta stack can handle 1,000 ONUs, 1,024 to be precise, across one or more OLTs. The Volta stack supports both OLT reboot and ONU reboot, meaning a full power off of an ONU, and both a soft reboot and a hard reboot of the OLT. So soft reboot is manually rebooting the OLT. A hard reboot is a power outage, for example. We also support adapter and core and different services failure restart. So remember, these are microservices. So we do support the capability of that microservice for some reason to crash and to restart. We call that reconciliation. And we handle that scenario. The infrastructure is very important that is highly available. So etcd, Kafka, and Onos are always deployed at least in a 3-node instance in a physical deployment to achieve that high availability. And everything that I've described up until now is in production. This is a key success that we had within the Volta community and at ONF in collaboration with all of our community and our operator partners, that both Deutsche Telekom and Turk Telekom now have live customers on the Volta system. So Volta, including Onos and the infrastructure, is deployed in the field, and there are live customers connected to it. Within Deutsche Telekom, it's as part of the A4 project, and it's live since December. Turk Telekom has done a lot of field trials up until now, and they also do have some live customers. The release that went into production is Volta 2.5, which is what I described up until now effectively. Some of the things that are in Volta 2.6 are key components for their operators, and they will look at possibly integrating them in their deployments going forward. If you want more details about these deployments, you can go and find them out in these two links. And you can also come and ask us for contacts, so we can actually provide you that level of detail and for those deployments. But what this demonstrates is that you can take the existing open source code and what we say run with it, meaning put it into production in the field, obviously surrounded by different pieces that each operator customized for their specific deployments. Volta is just a piece of the end-to-end operator solution, and I know both Deutsche Telekom and Turk Telekom have differences in the systems that they have at a higher level than Volta. But Volta itself can handle production deployments. So this is great news. Obviously, there's always something new that we can add to the system. So every new release comes in with new features. And after going into production with 2.5, there were some key elements that were needed to be added to the system. So Volta 2.6 does some of that. The key features of the Volta 2.6 release, which was released December 18th, are the OpenONU adapter in Go, the multi-stack support, scale improvements, the upstream charts for Bitnami and Kafka to avoid using incubator charts. We are also enhancing testing and continuous certification. And we also do support OLT software upgrade with an in-band mode to the use of BAL 3.4.9.6 for some features. We also implemented some bug fixes. For more release notes and more like detailed things about Volta 2.6 release, you can go into the docs.volta.org, and there's a page for the Volta 2.6 release where you can find more details. Right now, I'll dive into some of the key elements of the Volta 2.6 release and why they were so important and so key for the future of the project. So one of them, and it's a year-long achievement, is the introduction of the OpenONU Go. So during the past year or so, we knew that the Python version of the adapter, the OpenONU adapter, had some shortcomings, especially in multi-threading and performance. It was written in Python, and for example, to achieve the 1024 ONUs that we said was the target for a single Volta stack, we needed 8 copies of the adapter with introduced complexity of how to deal the exact number of ONUs to each adapter. So as I said, almost a year ago, we started a complete rewrite of the adapter in Go. That is because Go supports multi-threading, and also because in this way, we could simplify the architecture. So what we did, we removed the 8 adapters in 2.6. We removed the 8 Python adapters, so substituting them with the Go version of the adapter that is feature pair, meaning that it has all the exact features of the Python version, but in a much faster implementation that has less resource consumption, and it enables a faster bring up time of 1024 ONUs, which again is our target. It also supports adapter restart, which was not supported in the Python version, but fundamentally is also the platform to integrate new features, such as the software update or a new software update, which we are already working on. And this was a key success, and it was thanks to our community, in particular a team from Adtran, that we brought this together to really achieve that scale that is now needed for production deployments, going higher than 1024 ONUs. 1024 was the target, and we have not yet pushed the adapter to higher than that, but we are confident that with the architecture that was put in, it will go much higher with absolute no problem. A key element of the adapter is that it uses the OpenOMCI spec. The other key feature for scalability and production deployments that was brought in 2.6 is multi-stack support. So up until now, we focused on single stack performance. But single stack performance, it was achieved, 1024 was our target for a single stack, so we achieved that. But then we need to go to a lot more ONUs in a single pod. So what we are now capable of is using the same infrastructure, meaning one cluster of ONOS, one cluster of etcd, and one cluster of the Kafka bus in 3 or instances each, are now capable of supporting up to 10 Volta stacks enabled at the same time on all of the 3 workflows, meaning that all 3 AT&T, Deutsche Telekom, and Türk Telekom workflows have the capability to be deployed on 10 Volta stacks on the same common infrastructure. And if you do the math, that enables us to support 10,000 ONUs with one infrastructure and 10 Volta stacks in a Volta pod. Each Volta stack can support a number of OLTs with, again, up to 1024 ONUs. The common deployment that we have seen is 2 OLTs, 512 ONUs each. And there is no change in terms of support, meaning that going to multi-stack will not restrict you in the capabilities that Volta has. It will support all the services and all the workflows that I talked up until now. Again, there are other scale improvements that we had to do to support this multi-stack. One of them is having the capability to do flow replication at the OpenOLT agent. That's an open source specific thing. Some of our partners that work with closed source adapters don't have this implementation, but it was enabling us to be much faster in replicating some of the flows down at the hardware level. We also parallelized some of the ONOS apps. Remember, we only have one ONOS for 10 Volta stacks. So we needed to do some more performance optimization in the apps. For example, we use multi-threading in AAA and HCP L2 relay, but also in the OpenFlow southbound to be capable of handling the number of messages that the 10 Volta stacks were sending up. We also used the relay agent option 82 to carry port information for DHCP to avoid the overhead of processing. We also rewrote the BBSIM SADIS server to support the 10 stacks because we were seeing issues with the previous implementation of the SADIS server that was not dealing fast enough information about the subscriber. One thing that I would suggest everybody to take a look at is, given that we are putting so much effort and focus on scale, we do have some scale tests. As you can see down here at this link, those scale tests are run nightly and daily, multiple times every day, and check that we always reach that number of subscribers. We can always bring up 1024 per stack and 10 stacks, both on master and on the release. So as I said, testing is to us fundamental. We talked about scale testings. We go up to 10 stacks, but we also introduced, given that it was a complete rewrite, a complete new suite of OpenONU Go tests. This to us is key because we always bring in a component with his tests. We always want to test the features that we bring in. Otherwise, we are not enforcing that that feature will not break in the future, because once you put in a test, you keep testing it. Also, we introduced in Volta 2.6 multi-OLT tests on hardware, meaning that right now there is a pod, namely the Berlin pod, which was kindly provided by Deutsche Telekom, that has 2 OLTs, and those 2 OLTs are now deployed under one Volta stack and tested, meaning that operations on one OLT do not impact the second OLT. Power off of the first does not impact the traffic on the second. And we do this cross-reference testing right now through Jenkins on our nightly runs. We also brought in device management interface tests. It's a first implementation. They are by no means complete, but we do now have a Jenkins job that tests the interface against a mock BBSIM implementation. And that's a stepstone to bring in device management tests for vendor devices that bring in with their device manager. And I'll talk about it later a little bit. So all said and done, just on hardware, we're doing 150 tests nightly that test the different operator workflows, different failure scenarios, error scenarios, OLT reboot, ONU reboot, crash of adapters. So if you go to this link that I posted here, you can see all those tests, and you can dive in precisely in all the different type of testing that we do per each workflow, per each operator. What those tests enable us to do is also a key feature of Volta and of ONF is the continuous certification. So those tests are, as I said, running on hardware. To be compliant with Volta, we need those tests to run on each hardware that we can certify. So we started, as many of you know, with edge core hardware in ONF. And as you can see in this particular pod, we certify nightly the XGS-PON OLT. We also do certify nightly the GPON edge core OLT. But recently, and I'm very proud of this addition, we started making progress on certifying the Adtran OLT. And this is the first time that in Volta 2.x, we bring in for certification, not proof of concept and not like ping testing, full end-to-end certification at an OLT. That is not the open OLT. So with Adtran, what happened is that they brought in their own adapter. Remember, as I was saying before, you bring in your adapter for your OLT. The important part is that it adheres to the core APIs. So they brought in their adapter, and we are deploying it via Helm on the Kubernetes pod. That adapter talks to the device and translates the requests from the Volta core to calls for netconf for the Adtran models to that adapter. And I'm very happy to say that the tests that are running very smoothly. And thanks to the addition of the Adtran OLT, we actually found out things in our testing suite that had to be made better. So the next time we're going to integrate something, it's going to be even smoother. I say in progress because we are in the process of working with Atran to make all the tests run and then having an official stamp of certification. And that's going to happen in the next few weeks. Also, very important, we don't just certify OLTs, we certify also ONUs. Here you can see the Circom FG 1000 ONU. That's a GPON ONU, and we use them both for the Atran OLT, which is a GPON OLT, and the EdgeCore GPON OLT, which again uses these ONUs. If you want more detail about the certified products, you can go into the Open Networking Marketplace and look at the different products that we have there. For example, we also have the aggregation switches that we use to be controlled with Trellis that are not OLTs, but we know work with Volta. So this is a key element that we are doing, and it enables us to show that Volta is capable of supporting, with no changes except the adapter itself, different brands of OLTs. With the Atran OLT, we're also going to be implementing the tests for the device management interface, and that's also something that we are working towards. And as I said, that's a 7712 aggregation switch for bringing in all the OLTs within the same network, effectively, and going to the upstream. The key element for the certification program is that the operator procurement is actually based on the certification. So a lot of our operators work with vendors that are certified. And we have more in the pipeline to come. Radis is going to come in the upcoming months with their OLTs for certification at ONF. If you're interested, your vendor, just join the certification program. So you'll be brought in and you work with us, ONF, myself, for example, for your OLT to work with our tests so that we can certify that your OLT perfectly is capable of working with Volta and deploying the different workflows and the different services for our service providers. So let me do a little bit of a recap of the capabilities that a Volta and ONOS solution provides. It can handle high-speed internet access, voice over IP, video on demand, and IPTV via multicast. It supports 3 different operator workflows with their differences, Deutsche Telekom, Turk Telekom, and AT&T. If a new operator comes in, we're going to integrate his workflow. It can handle different PON technologies and different ONUs and OLT vendors based on the certification. There's 1,024 subscribers per Volta stack. It goes up to 10 stacks, 1,024 each, based on a common infrastructure. It does failure tolerance via reconciliation within the stack, meaning that an adapter goes down, but it restarts, reads data from the core and a TCD, and is capable of handling, again, the devices. While the infrastructure leverages high availability via replicas. As I said, we usually deploy 3 replicas of ONOS, 3 Kafka, and 3 etcd elements for each infrastructure of Volta. We have a nightly regression set of tests that run 150 tests on hardware, but we also run the nightly scale tests. That's even more tests. And this is deployed in production within our operators, Deutsche Telekom and Turk Telekom. So let's look a little bit further down the line. So in 2.7, which is upcoming in March, we are gonna introduce the ONU software update, and that is a key feature that we are gonna do in 2.7. We're also working on PPPoE for 2.7. Also, we are looking at possibly integrating, but that might be a little bit beyond 2.7. It depends on many pieces that are coming together. MPLS pseudo-wire support at the OLT, where the OLT is the endpoint of the MPLS pseudo-wire towards the rest of the network. And also multi-uni support and Mac learning. Those are probably not going to happen in 2.7, but further down the line. But this is just to put it on your radar. These are things that we are looking at. In terms of security and deployment, we're looking at external API encryption, the use of gRPC for inter-adapter communication instead of Kafka, and also the distinguish between OLT reboot and channel disconnect. Again, as different things come into priority, these might happen in 2.7 or might happen down the line, but they are on our roadmap, which is key. For deployment support, we want to do Volta software upgrade, both a minor version software upgrade and major version software upgrade. When I say minor version, it means no change in the APIs, no change in the data store. And major version, I mean changes in the API and changes in the data store. That the difference is key because there's going to be a lot more reconciliation happening in major software update, and it might the support for this might happen in steps. Obviously, we're always looking at scale improvements. For example, in 2.7, we're looking at IGMP join leave messages for Turk Telecom to test that at scale. We are also introducing performance metrics for the ONU in the OpenONU Go adapter. Obviously, as I said, this includes testing for all these features. We don't put in something that is not tested. And when I say testing, it means both software-based testing with BBSIM, hardware-based testing on the physical OLTs, and possibly scale testing if needed for that feature. As I mentioned, we're going to look at expanding our certification program. If you're interested, join us. I know Radisys is working towards this goal. We also encourage you to participate in this document that I linked over here. It's a wish list. It's not exactly a roadmap. We are getting things out of that wish list to do Volta 2.7. And that is in the process of being prioritized with our operators. We have weekly meetings with operators and TST, and there happens the prioritization of the different features that we want to put in the Volta 2.7 release, which again is going to happen at the end of March. Before I end, I want to give a huge thanks to the community. All of what I've been talking about would not have been possible without the folks that work with us. And all of the companies have played their role, their piece, and are key components within the community. It all starts with our service providers that work with us as ONF, but together with them, we build this ecosystem of vendors, system integrators that are all partners in the sense that all participate in the community and work with us to achieve the same goal, which is putting Volta into production successfully and always increase it and make it better. So my huge thanks and gratitude to all of this. I'm not going to make any names of people that really did participate, but there are incredibly good folks in this community, which I cannot thank enough for the great contribution that they have made. So just a follow-up, docs.volta.org provides a good overview of what I talked about and how to get you started. And if you have any questions, I'll go through some of them that just came into the chat. So thanks for that. But if you want to talk about it later, that's my email. It's andrea@opennetworking.org. We're a fairly small company, so we are lucky enough that it's just first name and it's simple to remember. And you'll just drop me an email and I'll be happy to talk with you about anything that is Volta related and is of your interest. So let me go to some of the questions that came into the chat while I was presenting. So the first one is about the slides. So thanks for asking. Yes, we will both share the slides and the recording of the video on YouTube in a very short time frame. And we'll send all the invite the participants an email with the link to the video and the slides. So that's done. Another one was asking what is device management like. The device management that I mentioned. Let me find the slide. Let's take. This one is good enough. It's just showing the figure. Maybe this one. The device management there is really about, for example, inventory. So things that Volta doesn't care too much about, like fans or power supply units, or things that are not the pertinence of the data plane. For example, what image is running on the OLT? Can we reboot this image? Or can we swap to the standby? Can we upgrade the image? What is the different type of settings that we can do for LEDs, fan speed? That is what we call device management. That is something that is not related to the data path of the user. Another question was about EPON. That's a very good one, and I actually forgot to mention it at the end in the slide, but there is already some work that has been done to support EPON within Volta by introducing a EPON adapter both for ONUs and OLTs. You can find in the repositories this information and the code. The plan is to have a demo at the Volta TST in the upcoming weeks. So to your question, yes, we are in the process of implementing EPON within the Volta stack. Another question was about the interfaces, and that's perfectly this slide. I didn't plan that, but the question was, are these interfaces between the adapters and the Volta core published so vendors can easily implement against protocols and message sets, or is purely data definitions mapping? The interfaces are public. So if you go at the Volta, in the Volta Protos GitHub link, you can see the protobufs that are used between the core and the adapter. And that also shows you the methods that the core can call against an adapter. Then my suggestion would be to use as a frame of reference the OpenOLT adapter. It's open source code. You can actually go and take a look at what everything does. Obviously, this is an engineer's work, meaning that there needs to be a team from a vendor that wants to integrate their own OLT that goes and take a look at the definition in the Volta Protos and at the OpenOLT adapter and makes sense of it and implements it. So the APIs are open source and you can definitely use them within your adapter. And that's what Adtran did for their adapter that I talked about before. So another question, and this is an interesting one, for which I might have to think a little bit more about, so I might get back to you later. But the question is, now that India only has 20 million broadband users, does Volta become a vendor operator neutral flavor right at the start as India scales for 100 million plus subscribers? So I cannot really share too much detail, but I know that Volta will play a part in the exponential growth of Indian networks in the next years. And there is already work that is going on towards that goal. Another question was about the state of NEM and XOS. So that is a very good question. And I have to say that unfortunately, it lagged a little bit behind. I want to be honest and does not say that it does complete support of the existing 2.x Volta version. It lagged a little bit behind because, as I mentioned, each operator decided to build their own components, northbound Volta, that control Volta. So the team at ONF decided, in conjunction with the operators, to focus on the scalability and features of Volta itself. So NEM is lagging a little bit behind, and that's the status of that. The second part of the question was, what is the reason for the limitation of the Volta stack to support only 1024? That was the initial target. So our operators said, as an initial good target, we want 1024. And that is mainly because you want regions of failure. So if a Volta stack fails, you're not going to fail 30,000 subscribers. You're going to fail 1,000. So especially at the start of the project where everything is new and also plans have to be put in place for this to work in the field, having that capability of surrounding islands of Volta stacks and OLTs to a fairly small number of subscribers allow you to not fail your whole network if a component fails, and iterate fast and restart fast on that particular stack. But we do have plans to exceed that number in the future. Another question was, given the microservices approach that Volta has, is it possible to deploy replacing other software modules in place of etcd, Kafka, and ONOS, with some example other brokers and ODL instead of ONOS? I have to say that is possible, meaning that the core has been written in a way that architecturally, you can go in and provide different pieces of code that talk to different brokers. It's not going to be a fast and easy task because, as you know, you would have, like you have for Kafka, you have to write the Kafka messages with a particular topic and you have to read Kafka messages with a particular topic. So those pieces of code, if you change Kafka for another message broker, you would have to rewrite. It's not impossible. It's not going to be a huge task, but it's not plug and play right out of the box. Another question is regards the PPPoE. So the question is, we are interested to know if a PPPoE intermediate agent feature will be integrated in Volta. We're also interested in the Mac learning features that we see was not integrated into Volta 2.6 and what are the plans for it. Thanks for both questions. PPPoE, I know that Furukawa Electric is working on it, and if you're paying attention to the Gerrit of the features that are coming in, there have been already some merges happening in the code to support PPPoE. The idea is to have a demo of that with all open source code in the next few weeks, and the support is going to come into 2.7. So that's PPPoE. For Mac learning, there are a couple of, so when I say Mac learning, it could go either way. So Mac learning of the subscriber or Mac learning of, for example, the different OLTs to support pseudo-wire. That's a little different. Those are two different Mac learning things. Mac learning for the subscriber, we do have an application which is called Mac Learning and was provided by Turk Telecom and is in the ONF repo. Unfortunately, is not yet plugged in the other apps. So the OLT app, for example, does not yet talk to that Mac Learning application. With the operators, we're working on what exactly the priority is because we have workarounds not to use Mac Learning and provision the subscriber with the Mac from outside. So we're working on the priority of that. The pieces are there. Again, it depends on what priority it is to make the final integration. A question is, we're very new to SEBA and want to train SEBA with Volta and hardware. What's the best way to start? Perfect. Go to docs. So I would say start with just Volta, so you get an understanding of how it works with hardware, and then you can plug in the other pieces. Docs.volta.org, the link that I put at the end, is the best for your initial work. Okay, so another question was a 10,240 subscriber with 10 Volta stacks in a common infrastructure. The question was, what is that infrastructure? So that infrastructure is comprised of ONOS, etcd, and Kafka, and that is usually deployed on 3 nodes. I can give you the spec of the nodes. I don't know them top of my head, but they need to have some RAM. SSD disks are important. And those servers are not very particular servers. These are not ONF certified products. We just use off-the-shelf servers. As I said, with x86 CPUs and RAM and SSD, I can give you the specs. I don't know them top of my head, but there's no specifics for those servers. They're just plainly available off the shelf. The other question that came, another question that came in is any plans to support microONOS? It's a very good question. At the moment, we are satisfied with the existing version of ONOS. That doesn't say that we will not go to microONOS, but at the moment, while that is a thought that might, for example, be included in a Volta 3.x release where we also play with P4 runtime, I have to say it's very further down the line that the timeline that we're looking at right now. So it's not completely excluded, and eventually it will happen. When that eventually is, I don't have an answer for you right now. Another question was, will a single Volta stack be improved to support 2K ONUs on a single OLT? The idea is to improve that number. Again, it's always a matter of priority and discussion with our operators and partners, but the idea is always to grow that number. The 1024 was also somewhat of a hard boundary for the Python version of the adapter, as I mentioned. Now with the Go version of the adapter, we can definitely go higher. We just need to make the tests for it, because it always starts with increasing the number in the tests and then see where it fails, and it's an iterative process. Another question was, is the device manager also collecting performance management data from the equipment? Yes and no. Performance metrics of the ONU and the OLT in terms of pawn data are collected to Volta and are published on the Kafka bus. Other metrics, such as temperature of the chassis, fan speed, other type of counters that do not pertain to the data plane, will be collected by the device manager. Another question was around the EdgeCore 7712. Is the Tomahawk platform EdgeCore S7712 32X is supported? Is my understanding correct? Yes, your understanding is correct. Let me go to this slide so I can show you exactly what I mean. So this particular switch is a 7712. That is an EdgeCore based with OFDPA installed. And that OFDPA is then used from ONOS to install the flow rules to provide cross connects from the upstream port towards the OLT and the port towards the BNG for the different subscribers. And that is why we say it's supported, because it's controllable by Trellis, and it supports the cross connect features that are required for Volta to be deployed. Another question was about what computing capacity is required for the 10 Volta stacks, and can we run it on a public cloud? So the first one, as I said, I don't know the numbers top of my head, but it's a 64 CPU, 64 core CPU, Xeon server, 3 servers with at least 512 of SSD each, and a bunch of RAM on them. I can send specifics, and they are published. For the scale numbers that we have, we publish the specifics. I don't know them top of my head. Can you run Volta on a public cloud? In theory, yes. Did we ever attempt this? No. So I cannot say it will work right out of the box. You're more than welcome to try it out. It's a deployment on Kubernetes, so it's easy to be testable on the cloud. It's just that ONF has never done it because with the operator partners, they would like to deploy it on premises. So that is why we never tried that. The other question was about the SX Volt from EdgeCore, which is the XGS pawn. Does it support the coexistence of XG pawn with G pawn? No, this box, the SF Volt 16, is only the XGS pawn box. I know EdgeCore is working on a box that supports both XG pawn and G pawn. We call an any pawn box or multi-pawn box, depends on what you prefer. I also know that others are working on the same capability to support multiple type of pawn technology within the same box. But this particular one, which you see here, the one there, it's just an XGS pawn box. Whenever another pawn box, another box comes that supports both of them, we will certify that. So the other question is, do we have any GUI interface to provision subscribers, especially bulk subscribers? To the GUI interface, no, for the same reason that I talked about them before. Each operators would like to keep it consistent with their previous deployment and their existing OSS PSS systems. So ONF did not provide, with the existing version of Volta, a GUI. Whenever we bring up NEM to this version of Volta, NEM has a graphic user interface that allows you to deploy subscribers. What we suggest is that you use either the REST API, the REST APIs of Onus to provision the subscriber, and there you can provision multiple subscribers. Another question was, who will provide the OLT device management component? That's a very good question. So at the moment is up to the vendor. We have an open source API that, an open source implementation on top of VBSIM that shows you how it's supposed to do. You're supposed to do it, but each vendor should come, as they said, as they do with their adapter, with their device manager. And we are working with EdgeCore for them to contribute also their device manager that implements the DMI interface. This is a very technical question, and that is, after an OLT reboot, the flows are restored from a local database or need to be reconfigured by Onus? It's a very good question. So as per our operator decision, an OLT reboot actually purges the OLT data from Volta. It goes in and removes the flows from Volta and from Onus. It's actually Onus that removes the flows, because the OLT reboot specifically goes in and removes the ports from Onus. Upon port removal from Onus, Onus will delete the flows. So those flows will be purged in Volta. Whenever the OLT comes back up again, Onus will rediscover the ports and repush, for example, EPOL flows. And those are also events that are published on the Kafka bus, so operators can react. Operators or SSBSS can react to it. Another question: so in the architecture diagram that there's only a layer of white box switches. Does that mean that the OLTs perform as leaf switches, or they part with trellis fabric? Good question. Maybe I go back and explain it on the slide. I suppose you're referring to this one. No, this is just a subset of the trellis fabric. The OLTs do not act as leaves in the fabric. They are connected to a leaf or multiple leaves in the case of, for redundancy, multi-homing and dual-homed OLTs. Here I show two of them. Usually trellis fabric is a 2x2 or 2x4. It can be also a single switch, as I showed in the pod, but the OLTs do not act as leaf switches. The other question is from Mario and says, what about chassis-based OLTs? It's a good question. So nothing prevents you to integrate chassis-based OLTs to Volta. The same way we integrated, I was talking about here, the vendor X adapter can be an adapter for a multi-chassis OLT. I know that some of these OLTs are very powerful machines, multi-chassis OLTs are very powerful machines that might have the capability to actually run some of the software on top of them. We have never tried that because that was never a request from our operators. But if the operators will in the future request us to run Volta on chassis-based OLTs, top of my head, there will be some work that needs to be done, but there is no major issue in doing so. And as I said, if you want to integrate an OLT right now, multi-chassis OLT right now, you can do so by bringing in your adapter that talks to that multi-chassis OLT, the protocol that it requires. Another question was about, and then I think I have time for, I think, one more, and I'll answer the ones that I did not answer via email, and I'm sorry if that is happening. Some of them actually, I'm going to actually answer a few of them, and they both handle in terms of how many the scalability numbers. So, how many OLTs per stack, and how many ONUs per stack. We don't hard code numbers, meaning that there's no hard coded limit of either a number of OLTs or a number of ONUs per Volta stack. The numbers I mentioned are the numbers we test, meaning that ONF says we are sure that if you try it with 1024 ONUs divided up to a handful of OLTs, we tried 2-3 OLTs per stack, we know it works. Everything outside of that number is uncharted territory, meaning you're more than welcome to try it. We just don't have the certification for it. We just don't have the test at the moment for higher numbers. But there is no hard coding, so you can try it. You can go ahead and try 2000 ONUs. It's just that at ONF is something that we have not tried. So it's uncharted territory. It might work, it might not. The request from our operators was, we are okay with 2 OLTs, 1024 per stack. It can be 3 OLTs, it can be 2000. We just never tried that scale numbers. And given that it's key to understand the capability at scale to have tests for it, we just, if that's of interest of some operators, we need to have an official request from the operators in our TST and in our roadmap to put that expansion together. And I will answer the SEBA in a box, BFF, OFBA, and XDSL questions via email. I'm sorry, we are just finishing at the top of the hour. So thanks a lot for joining. I really do enjoy work with the group and the community, and I do hope that this talk inspired you to join the community, given the great work that we have done. As I mentioned, please go take a look at docs.volta.org or drop me an email, and I'll make sure to answer everything that you're interested in. Thanks a lot, and have a great evening for those of you in Europe, and day for those of you in the United States or Americas. Thanks a lot. Cheers. Bye bye.